So today we're going to be doing absolute value equations. Now, one of the key concepts of absolute value equations is the idea that we are going to be taking two different versions of an answer. You're going to get not one answer, but a second one. And that stems from the idea that absolute value equations do the same behavior as their regular absolute value counterparts. If, for example, let's say I have the absolute value of, let's say, x, which is equal to 7. The absolute value of x can be either positive 7 or negative 7, because the absolute value of which is 7. We can go both right on the number line or left on the number line. Again, because absolute value, as far as the number line goes, is a distance. So I can go a distance of 7 in this direction or a distance of 7 in that direction. I'll end up at this point on the number line or at this point on the number line. So we're going to split our answers into two possible answers because, again, with anything like this, you end up with a very similar thing. So without further ado, let's jump into this. So number one. Now, the way that we're going to solve these absolute value equations is that we are going to isolate the brackets. There are other ways to do this, and there are exceptions to the rule. But again, when we start getting into 2 and 3 absolute value brackets in a single equation, this method's going to be true throughout all of them. You're not going to learn a new method. So in essence, once we isolate the bracket, like in number 1, the bracket is already isolated, we can go ahead and do a split. And what I like to do is I like to say, okay, let's split this into what I call the positive and the negative side. Now, the positive and the negative side, where does that come from? Well, remember what we talked about with our number line, where we're going to the left and to the right. Well, if we're going to the right, we can look at our equation as normal. We can say, okay, it's going to be 6x equals 42. And now I'm going to write this 42 in blue, and you'll see why here in a moment. Now, to go in the other direction on the number line, I'm going to do a 6x equals a negative 42. Now, you might ask, why did you do that? Well, with the positive side, what we did was, in essence, we multiplied a positive 1. Let's see, we already have that in blue, so let's go ahead and write this in green. So we're taking this number, the thing that is not within the absolute value brackets, and we're multiplying it times the positive 1. So 42 times positive 1 is 42. Separately over here, to go in the other direction on the number line, I'm taking 42 and I'm multiplying it times negative 1, which makes it a negative 42. Boom, so we got both directions on the number line. Now at this point, I can go ahead and I can say, hey, let's separate this into two pieces. Divide this side by 6, which is going to give me an x equals 7. Perfect. If I come over here, I'm going to divide this side by 6, which is going to give me an x equals negative 7. Perfect. And so as of right now, what I want to do before I list my full answer is I'm going to check both of these for validity. Because the most important thing to do with an absolute value equation is to plug our work back in to make sure it actually works. So let's try this out in purple. I'm going to plug that 7 into the original equation. So I get absolute value of 6 times 7 is 42. So the absolute value of 42 is 42, which means 42 equals 42. That answer works out. I'm going to do the same thing to negative 7. I'm going to plug that back into the original equation. So the absolute value of 6 times negative 7 is 42. That's going to be the absolute value of negative 42. The absolute value brackets, once we've isolated this, is going to convert that into a positive number. So 42 equals 42. So that has been validated, which means that my answer set is going to be x equals negative 7, comma, positive 7. Boom. And there we go. So we can see it's not too terribly complex. Let's jump up to the next one, number 3. So on number 3, now with this, again, there are other methods to do this. We're going to practice the method that's going to be isolating these brackets before doing anything else. Now, if I consider these brackets a thing, is there anything outside of the thing? Yes, there's a 7. So I need to get rid of the 7 first. So I know that 7 is connected via multiplication, so I'm going to divide this and this side by 7, which is going to allow me to have an absolute value of n is equal to 8. So on the first problem, we were already isolated. Nothing was outside the brackets. On this one, we had something outside of it that we needed to get rid of first. But once we get to this point and the brackets are isolated, we split into our positive and negative version. Now remember, what are we multiplying times a positive and negative 1? The thing that is not inside the brackets that we're splitting. So it's going to be this 8. So over here I have n is equal to 8 times 1, which is 8. Then over here I have n is equal to 8 times negative 1, which is negative 8. Perfect. And so in this case, I would continue to solve for these, but I don't need to. I have a positive 8 and a negative 8, which means that I'm going to go ahead and I'm going to check to see if these work in the original equation. So I'm going to plug in 7, absolute value of 8 is equal to 56. The absolute value of 8 is 8, so it's 7 times 8, which is 56. That answer is validated. Do the same thing with negative 8. So 7 times absolute value of negative 8. Absolute value of negative 8 is a positive 8. 7 times 8 is 56. So that answer is also validated. Perfect. So there we go. That means our answer set is going to be n is equal to negative 8, comma, positive 8. Now you might ask yourself, why am I putting the negative first? Well, out of my two answers, the negative is the lowest in the number line, so I'm going to put that one first, and then the bigger one second. Perfect. So now that you've seen that, why don't you go ahead and give number 5 a shot? You'll notice that I have some more going on inside the brackets. See if you can figure out what you need to do before you split it, and then solve it. So pause the video and pause when you're done and see how well you did. Okay. So if you notice with this, the absolute value brackets are already isolated, albeit I have a minus 54. I'm not doing anything extra. So I'm going to go ahead, I'm going to split this into the positive and the negative version, which means I'm going to take this, y minus 54, and I'm going to set it equal to a 37 times positive 1, which is 37. And then over here on the right, I'm going to keep my y minus 54 is equal to 37 times negative 1, which is negative 37. Let's make sure that with an equation like this, oftentimes what we see is that students will look at that negative sign and be like, well, in an absolute value bracket, I can't have a negative, and they'll erroneously come in and try and turn this into a positive before working. Well, albeit that's well-intentioned, the process inside the absolute value brackets has to hold true. So now that I have my positive, my negative versions, what I'm going to do is I'm going to go ahead and I'm going to finish solving these. So if I drag my line down, I add 54 to this one, which is going to cancel out the 54 on the left. And I get y is equal to whatever 54 minus 37 is. Let's see, that is going to be 24 minus 7. It's going to be 20 minus 3. That's going to be 17. For my other one over here, I'm going to add my 54 just like before. Plus 54. Written very poorly, but oh well, we get the idea. Y is equal to 54 plus 37, which is 91. So we're going to check our work on both of these. And I get, let's see, 91 minus 54 is 37. 37 is equal to 37, which is 37 is equal to 37. That answer checks out. For my other one, 17, I'm going to plug that back into the original. Absolute value of 17 minus 54. This is going to give me my negative version of my answer. So negative 37, the absolute value of which is a 37. So that answer validates. So in this case, this is the first time where I don't see a positive and negative version of my answers. My y is equal to 17, 91, which begs the point to mention that oftentimes when we see absolute value questions in the beginning, you're given easier problems where, hey, cool, it's a positive negative version of itself. So oftentimes what students do, and don't fall victim to this, is they'll solve one of the two. They'll say, okay, I'm just going to ignore this and make my answer positive and negative, just like that. Now, on this question, you could get away with it. On this question, you could get away with it because you have a positive negative 8, positive negative 7. But if there's anything going on inside those absolute value brackets, you can't get away with doing that trick, because if I said positive negative 91, I would not have checked out with the negative 91. So again, always be careful, always work it out the second time. Don't try and shortcut and say, well, why don't I just write out my answer twice with a positive and negative version of itself? We see from here that is not always the case. Perfect. So what that's going to do is that's going to lead us to our second set of problems. Let's take a look at the first one. Okay. So this one's similar to one of the ones we've done previously. So what we're going to do is we're going to isolate our absolute value brackets beforehand, which means I need to subtract this 44 from both sides. Okay, and when I subtract that 44, what that does is that isolates my set of brackets. See, 110 minus 40 is going to give us 70. That's going to be 66. Perfect. Now that my brackets are isolated, now I can split into my two equations. I have my positive side and my negative side. Again, what I'm going to do is I'm going to multiply what's outside the brackets, the 66, times a positive one and times a negative one, and get two separate answers. So x equals 66 times positive 1 is 66. 66 times negative 1 is negative 66. Again, we like ones like these because in this case, I don't need to do anything further. I am just going to go ahead and I'm going to try and plug this in and check this. So when I plug in 66, absolute value plus 44. 66 plus 44 is 110. That answer checks out. We do the same thing with the negative 66. Okay. So that negative absolute value turns into a positive 66 plus 44. It's really difficult to write with the repeating numbers. 110 is 110. That checks out as well. Perfect. So that means my answer, my solution set is negative 66, comma, positive 66. Awesome. And so that leads us into this one. So what I want you to try is I want you to pause the video, unpause it when you're done, and see how you did on this one. Give it a shot on your own. Okay. So now that you had a chance to try it out, let's go ahead and check this out. You should have subtracted the 13 as your first go, which would have left you with the absolute value of 7y is equal to 70. Now that my brackets are completely isolated, I'm going to split this into a positive side and a negative side. I'm going to multiply this 70 times a positive one and the 70 times a negative one. So that's going to leave me with a 7y equals and a 7y equals. 70 times positive 1 is 70. 70 times negative 1 is negative 70. This leaves me with two steps left. One over here where I divide by 7, and I get a y is equal to 10. One over here where I divide by 7, where I get y is equal to negative 10. I check out both those answers by plugging them into the equation. So I get absolute value of 7 times 10 plus 13 is 83. Over here, I would plug in the absolute value of 7 times negative 10. I'm going to work both these out to check to see if this is a true answer and if this is a true answer. It's going to be absolute value of 70. This is 70. This is 83. That checks out. Absolute value of negative 70, which turns that into a positive 70, which gives me 83 equals 83. That checks out. So my solution set is y is equal to negative 10 comma positive 10. Perfect. Okay. And now the final question that we want to work on today is going to be question 11. Now question 11, again, we're going to see something slightly different, something that's outside the brackets, but go ahead and try and solve this one. Pause the video, unpause it when you're done, and see how well you do. Okay, so now that you've had a shot, what we notice this time is there's nothing added or subtracted, but that 8 is outside the brackets. So how do I get rid of a divide by 8? I multiply times 8. Now when I multiply times 8, times 8 divide by 8, those cancel out. And I'm left with over here on the left, the absolute value of negative 4 plus n is equal to 48. Again, be careful, because what a lot of students will do is they'll turn that negative 4 into a positive 4 because they want these absolute value brackets simply to make everything positive. That's not the case. What it's going to do is it's going to allow us to split this into two equations and solve for two different answers. Over here, I'll get a negative 4 plus n equals, and a negative 4 plus n equals, multiplying by the 48. 48 times 1 is 48. 48 times negative 1 is negative 48. Once I get those two, just add the 4. Over here, I'll get n is equal to 52. 52, not what I just wrote. It's 52. Over here, when I add the 4, that's a negative 48. So when I add 4, it becomes a negative 44. Perfect. Now, if I try plugging both these numbers into the original equation, absolute value of negative 4 plus 52 equals 6. And I get the absolute value of negative 4 minus, so it's plus a negative 44, which is going to end up being minus 44. Perfect. So over here, 52 plus negative 4 is going to be a 48. Absolute value of 48 is 48. 48 divided by 8 is 6. That checks out. Two negatives added together make a bigger negative, so this is negative 48. Absolute value of negative 48 is 48. And 48 divided by 8 is 6. Both those answers check out. So what I get is I get an answer set of negative 44, comma 52. Boom. And there we go.